Okay, in this lesson, you're going to really get grilled on this CPCTC. It's really important you understand this. So let me start by just getting to the idea of what corresponding parts are. Okay, they're matching parts. Kids seem to understand the concept of matching parts. So if I had two triangles, right, you should be able to look at them and say, hey, this side matches that side, right? Well, in math class, instead of saying that they match, we say that they correspond. Okay, and we're saying if the parts match or correspond and they are congruent triangles, so we already know that those triangles are congruent in every single way, well then those parts have to be congruent. That's what CPCTC is, okay? It's simply saying that the corresponding parts of the congruent triangles are congruent, okay? And hopefully it'll make a little bit of sense to you. This is a good little visual I like a lot because I always see this as a lot shorter than that line, but if you get out your ruler and measure, you're going to find they're exactly the same length. Now here it says, whenever you want to use CPCTC, first you have to identify the two triangles and find, the parts, which are either the segments or the angles, and show that they are corresponding parts. Then you can prove that you go through the work of proving the triangles are congruent. And if the triangles are congruent, you just simply say, well, then the parts must be congruent using CPCTC as the reason. So in your statement, you say, okay, this side is congruent to that side by reason CPCTC, okay? Corresponding parts of congruent triangles are congruent. So we're going to create a proof of the following. You have this diagram here. What we know is that CW and SD bisect each other, which tells me this segment CP, it has to be congruent to segment PW because of the definition of a bisector. Same thing with SP and PD. Since they bisect each other, this side has to be congruent to that side. So now you have the hypotenuse and the leg of right triangles here. Therefore, by hypotenuse leg, you can prove that they are congruent. Or you could do vertical angles here. CPS is congruent to WPD by vertical, right? So those angles right there, then you'd have side, angle, side. Right? These two sides were given to you as the given, and then you just need to state vertical angles, and then you have side, angle, side. Now we have triangles that are congruent. Well, if triangles are congruent, then their corresponding sides have to be congruent. So, the corresponding parts. So you have CS and WD, they must be congruent by CPCTC. Okay, and here you have another one. I would recommend with these that you actually, off to the side to help you a little bit, I usually draw these triangles. They want you to, we're going to be working on angle U, and if you look at U, that is this triangle right here. It's part of triangle SUH. I just draw that over here, SUH, a sketch of it, right? Just to help you keep track of what you're doing. And then you have angle K, which is part of triangle SKR. And just looking at those two triangles, if you draw them out separately, it will really, really help you. So given that SU is congruent to SK, that's one side each. That's the long side of these little triangles here. Then you have SR is congruent to SH. Those are the short sides of the corresponding triangles. So you have two sides already that are congruent. And then if you notice carefully, both triangles have the same exact angle S. So angle S, side, angle, side, each of these triangles should be congruent by side, angle, side. If the triangles are congruent by side, angle, side, then you have angle U and angle K being congruent. And here we have, you're going to prove the isosceles triangle base angle theorem. We usually call this the base angles theorem, or BAT. And basically what you're going to do is you're going to say, all right, I've got a regular triangle, and all I know is that it's isosceles, meaning that GD is congruent to GB. That's all I know. And what we do then is we say, okay, well, let's construct here a segment that bisects segment DB. And so you would state, GU bisects DB, and the reason you give is construction, right? Here's what it says, is when you add a segment to a diagram, use the reason construction. So you would just say GU bisects DB by construction. Therefore, DU is congruent to UB, GD was given to be congruent to GB, and GU is congruent to itself. So by side, 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 these two triangles must be congruent. And if the two triangles are congruent, corresponding angles are congruent, and B corresponds to D by CPCTC. Now we're going to do the converse. This is just moving the opposite direction. So in other words, we don't know that this is an isosceles triangle. All we know is that angle D and angle B are congruent. That's the given. So now what I do, if this is angle B and this is angle D and it's congruent, is now I would make a different construction. Instead of bisecting this side, I would bisect the angle. And that way, if you bisect the angle, you're going to have angle BGU be congruent to angle DGU. So this little angle and this little angle, if you've bisected them, that's by the definition of a bisector, these two angles will be congruent to each other. Therefore, because these base angles B and D are congruent, and this bisected angle is congruent to each other, and then furthermore, this side is congruent to itself by the reflexive property, we have angle, angle, side, and again, angle, angle, side. The two triangles have to be congruent to each other. Well, if they have to be congruent to each other, then corresponding parts, GD and GB, must be congruent by CPCTC. And that is how you prove that one. All right, so now we have what we should recognize. These are right triangle. See the perpendiculars that have been, when you have two sides that are perpendicular to the same edge, then what you have here, two line segments that are perpendicular to the same line segment. That means they must be parallel to each other, okay? Then what we have here is we have a transversal. And in a transversal, we have one angle and another angle that are congruent by alternate interior angles. So angle, angle, side. Again, angle, angle, side. The two triangles have to be congruent. Therefore, if this comes out 45 feet, then the corresponding side to this triangle 45 feet as well. In this one, what I do is we'd notice that, hey, I've got two angles that are congruent. If the two angles are congruent, the sides have to be congruent. So that's AY and AP must be congruent. So I'd call this one X and this one X. And then I'd add it all up. You end up with 2X plus 13 equals 43. And then you write that equation out, 2X plus 13 equals 43. And solve for X by subtracting 13 and dividing by 2. A little algebra. This one, I didn't really like this question at all. I thought it was a little bit difficult to understand what the question was. But the idea is that you're going to have these four beams going this way. You notice all these beams on the Ferris wheel have lights. See that? But these four do not have lights. You have to order lights for them. So there's 1, 2, 3, and 4. Those are the long beams. And then you have these short beams, which are 5. You have 3 of them, 1, 2, 3. We don't have to put lights on these beams. So really, if since these are congruent isosceles triangles, then if this one's 25, that one's 25, that one's 25, and that one's 25. So to get enough lights, you need how many feet? I would just take the 25 times 4 and you'll get the answer. All right, this is a good one here. This is clearly an isosceles triangle. And this right here forms a linear pair, so they are supplementary, and this should be 180 degrees. So if you subtract 117, you'll get the measure of angle M, the interior angle M right here. And since these sides are congruent, then the interior angle W has to be the same as M. And you can find out angle T by taking 180, subtract this, subtract that, and you will get angle T. Here we have another one right here that is very similar. We have 42 feet by 42 feet. That's a side and another side. And here you have an 80 foot and an 80 foot. And then you have a pair of vertical angles. So you know that side, angle, side are congruent. Therefore, the triangles are congruent by CPCTC. The corresponding parts have to be congruent. This part here, this side length here, 65. Therefore, that side length has to be, you guessed it, 65. Now, given that ST is congruent to SR and that TA is congruent to RA, explain why you know that angle T and angle R are congruent. Well, I would say just as long as I connected SA into a segment, I'd have two triangles. SA is congruent to itself. These sides are congruent. These sides are congruent. Those were given, all of those. So we have the reflexive property given, and given that side, 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 we have triangles that are congruent, and then these are the corresponding parts. So by CPCTC, angle T and angle R are congruent. And that is all that you have to do for 8.2.